morning, we're going to go over organizing our data when we have quantitative data, that is discrete and continuous data. So, of course, we want to determine whether our data is discrete or continuous because when we have discrete data, we organize it slightly different than we have continuous data. Typically, with discrete data, each answer, each number gets its own category, unless there's lots and lots and lots of different answers. On continuous data, we typically classify them. We put them into classes. So we'll see an example of both. Here's an example of some discrete data. How many vehicles do you have available to use at your household? The smallest number is 0. The largest number is 5. So it makes sense that each number gets its own bar or own line in our frequency distribution here. So remember, to find relative frequency, we take our frequency, like 4 or 13 or 22, etc., and divide by the total number. And we are making a proportion, what proportion of survey takers answered 0 or 1 or 2, etc. Now we can have a frequency histogram, or we can have a relative frequency histogram. Remember, a histogram is just a bar graph where the bars touch. And if you look here, this is a frequency distribution. Our increments going up the left-hand side are numbers of cars, and we go by 5s here. On the other hand, our relative frequency is the proportion of cars. So just under 10% of our respondents answered 0, just under or just over 40% answered 2. Now, if we have continuous data, what we typically do is put them in categories. In this case, we've categorized them by age. Each age does not get its own line in our chart or own bar in our graph. Instead, we put them in categories. These lower values in each of the categories or classes are called a lower class limit. The upper values in the classes are called the upper class limit. And then the number of values that each class takes into account is our width. It looks like the width here is 9 because our default brain position is just take the higher number minus the lower number, but that is not how you do it. The class width is taken or gotten by taking 35 minus 25. So subtract 2 successive lower limits, or subtract 2 successive upper limits, like 64 minus 44. This data is the number of seconds between eruptions at the Old Faithful geyser at Yellowstone. You see they're all over the place. So this is discrete data, but there's so many different values, it doesn't make sense for each piece of data to get its own line in my chart or own bar in my graph. So we'll decide to start at 670, even though our smallest value was 672. There's no rule there. Our largest value was 738. So if we go from 670 to 679 in our first class, that's a width of 10. We can go up to and include our highest value. And here's what it would look like. We would set up our classes over here. Then we'd go through and count how many of the different responses were in that particular class. Write our frequency and calculate our relative frequency. Now, how do you know what to choose? Well, it's kind of up to you. Your book says they're arbitrary, but if you have different class width, for example, this is a class width of 5, you end up getting a different look to your graph. It's not way different, but it's a little bit different. What you typically want to do is choose the smallest number or something that's convenient, like we had 742 and we picked 740. And generally you want between 5 and 20 classes. No less than 5, but at least 20. Then we make our frequency table and we can draw our chart. So this is a chart based on a width of 10. Here's a chart based on a width of 5. So it's very similar looking, but it's not exactly the same.